Welcome to today's tutorial on trigonometry with obtuse angles. Now this is one of the more challenging concepts within trigonometry, I guess just to understand. Okay, obviously we've been looking at right angle trigonometry, and we've been using our rules for our SOHCAHTOA, okay, within the right angles. So a couple of things I'm going to point out. To start with, we're going to be looking at the angles within the right angle triangle. So what we're going to look at is, we've got a grid here. We're simply going to look at a right angle here, and we're going to be looking at theta, obviously the angles. We're going to call this the point A, B. Okay, so that's the point AB. Remember, our A is the x coordinate, B is the y coordinate. This would mean that our A would be the length, I guess, of the base of the triangle, and the B would be our height. So if I was looking to write out some trigonometry ratios for SOHCAHTOA, in this case, actually we've got to put I should put my C on there as well. Okay, we could look at our sine theta. In this case is opposite over hypotenuse, our B over C. Our cos theta is adjacent over hypotenuse, so A over C. And our tan theta equals our opposite over adjacent, B over A. Now I know this is just general stuff, so obviously there's no actual values, but something to point out, that when we talk about, I guess, angles within our first quadrant, remember this is called our first quadrant, because it's the first quarter of our plane. All our values here are positive. So when we're looking at, and I guess if you talk about this particular angle and want to give it a sort of a type of angle, we call this an acute angle. So when we talk about acute angles within trigonometry, our values are always positive. Okay, as you can see, they're in the first quadrant. It works out that way. But sometimes we look at what we call obtuse angles. Now, you might say, well, what do I mean about obtuse angles? What happens if we had a triangle such as this? It's not very straight there. Okay, we want to find theta. Now obviously with right angle trigonometry we can't find that. So what I'm actually going to do, I'm going to draw a right angled triangle here. Okay, and I'm going to talk about theta there, because if that's theta, if I know what that angle is there, then this angle is simply going to be 180 minus that amount. Okay, so what I'm actually going to be looking at is the distance, or the right angled triangle on the left hand side. Okay, this is where we're going to, and this is the reason why I'll be showing this first step. I'm going to come back to this. So sometimes it is useful for us to look at, as we saw, this right angled triangle in the second quadrant. Okay, the second quadrant there. And I've come back to this because I want to look at the values that we used here. Obviously, if that's B, okay, that's our y-axis, this is still B, okay, this is still positive. But what about our x values? If that's A, that becomes negative A, because it's on the left-hand side of our x-axis, of our x values. And this is still going to be our values of C. And I want to see what happens in this situation. So if we look at our sine values for the second quadrant, our sin is B over C. Our cos is our adjacent, which is minus A over C. And our tan values for theta is opposite over adjacent, so B over negative A. And what you're going to notice, in the second quadrant, sine is still positive. However, our cos and tan values are actually negative. Okay, our actual cos and tan values are negative. Sometimes we have a rule that might help people, and we often use this rule called all stations to Cronulla, or all stations to Central. All stations to Cronulla or Central. And what that means, and obviously we're only looking at the first two quadrants, but actually it means that all the signs, sin, cos and tan, are positive. In this one, it just means sin is positive. So it means that our cos and tan are actually negative. In the third quadrant, it means that tan is positive, sin and cos are negative. Cos is positive, sin and tan are negative, etc. Now we don't deal with that bottom part, okay, in general maths. We're just focused on those top two parts. So again, you're thinking, well, okay, I know that my sin values are positive for the first and second quadrant. I know that my cos and tan values are only positive in the first quadrant. I can understand that, but what does that mean? Well, first of all, we can check some values. So let's say, for example, I'm given a value of cos 140 degrees. Okay, straight away you can see it's an obtuse angle because it would have to be in the second quadrant because it's 140 degrees. So the fact that we know it's in the second quadrant, I can automatically guess that cos is negative in the second quadrant, so cos 140 will be a negative value. So let's do that on our calculator. We get 0.766 to 3 decimal places. So it's negative. If I get a value for sine, and it's sine 30 degrees, because we know it's an acute angle, because it's 30 degrees, that means it's in the first quadrant, I automatically know that the value of sine 30 is going to be a positive value. In this case, sine 30 equals exactly 0.5, which is positive. Let's say, for example, I know that tan theta is negative 0.756. And I'm asked to find, or say, whether or not theta is an acute angle, or is it going to be a positive value? Okay, so is it going to be an obtuse angle? Well, straight away I know that tan theta can only be negative, in this case, in my second quadrant. So I automatically know that theta is going to be an obtuse angle because it's negative. Okay, but you might not have worked something out yet. There's actually an issue with this. If we were to actually find out the value of theta, okay, now you could either put that straight into your equations mode to solve for theta, or you could press shift tan and your answer, so shift tan, negative 0.756. We do that in our calculator. We come up with a value of minus 37.09 degrees. Now obviously we can't have a negative degree, but not just because of that. We've got an issue because we know that it has to be obtuse, but we've come out with 37.1 degrees. So something's going on here. So this brings us to the whole reason why we're doing this. So I'm going to show you what we found. We've actually found this angle in the second quadrant here, and inside there to be 37.1 degrees. The issue is we're being told that it is not an acute angle, it's actually an obtuse angle, and what we're actually finding, so I'll use a different colour there, we're actually finding this angle there. Okay, how would I find that angle? If I know that's 37.1 degrees, well, what we would do, we would simply find the supplementary angle, or which means take that away from 180 degrees. So if we do that, we do our 180 and we take away that 37.1, we're left with 142.9 0.9 degrees. So we can actually find that angle because we know it's obtuse, okay, by doing that. Now this brings to particular rules, okay, that we have to remember, and we've already spoken about the all stations to Cronulla business. So what we can come up with is a statement. I'm going to just redraw my triangle there, put that as theta. So we've got some rules that we have to remember. So I'm going to say that sine, because remember this is 180 minus theta here, sine 180 minus theta is equal to, remember this is the sine in the second quadrant, which is positive, so it's sine theta, cos obtuse angle 180 minus theta, remember that's the obtuse angle, is equal to, because it's in the second quadrant, negative cos theta, and then which is the same for tan, so the obtuse angle of tan, which is 180 minus theta, is equal to the negative tan value of theta. Okay, now there's some pretty important rules to remember, but I'm going to show you a really easy way to think about this, a really easy way. Okay, so questions that will be given will be things like this. If the angle is obtuse, find tan theta equals -1. Okay, so you would solve this as you would usually do. In your calculator, we're pressing Shift tan -1, or if you want to put tan x equals -1 into your equations mode, and it comes out to be theta equals -45. Okay, obviously that's not an obtuse angle, so what we want to do is simply find the supplementary angle of that, which is simply 180 take away 45, which is going to leave us sitting out here with 135 degrees. And it's as simple as that. If it's not obtuse, okay, for example, it's acute, it comes out, then obviously just take it away from 180. Likewise, we're going to do sin theta equals 1/4. So put that into your equations mode, or do shift sin, that's up to you which one you want to do. 1/4, press equals. Now remember, we want it to be an obtuse angle, we get 14.5 degrees. That's not obtuse, so let's simply do 180 take away 14.5. We're left with theta equals 165.5 degrees. Simple as that. So just be careful. If they actually say that the theta is obtuse, just make sure that when you put that calculation into your calculator that it comes out obtuse. If it doesn't, take it away from 180 degrees, Bob's your uncle. That is all they are going to ask you about this stuff. Otherwise, it's just going to be more of the harder questions on the sine rule and the cos rule. Okay, I know it's confusing, but if you can just remember, type into your calculator, if they're telling you it's not obtuse and it doesn't come out to be obtuse, just take away from 180 and you're sorted.